Good morning, everybody. So, my talk will be a little bit more technical side. Keeping this standardization activity a little bit aside, let us focus for some coming 45 minutes in the technical beauty of this upcoming technology. The joy of doing research in this new area and this remarkable transformation that has happened in the history of communications from this age-long narrowband communication research to a very wide band, high frequency research. And where we all the fundamental researchers are feeling that the communication theory also needs to be revisited for lot of the cases. And so the information theory people on the one side, the signal processing people on the other side, and also the device people on the third side, along with the network people are struggling all together all over the world. So I will try to show you all those challenges and the beauties and the new stuff that have come up for us. If we this, then next it is up to us, the way the researchers will utilize this and the way it will be really used for the benefit of the mankind for that next generation. See, we were in the microwave over the long years, and this millimeter wave communication, the range starts from these 3 gigahertz to 300 gigahertz. Literally speaking, these days after 100 gigahertz, we have started talking about the terahertz communications also. Because lot of the industrial products already in the prototype version came also in the 77 to 81 gigahertz. 60 gigahertz products are also little bit available for short range communications. Low range 28-30 gigahertz for the outdoor communications, the vendors are up to coming up with their stuffs. So people, the research has already started in the area of 100 gigahertz and above. So before entering a little bit about the School of Telecommunications, GS Sharma School of Telecommunication is a IIT Kharagpur initiative which happened 2 decades back to dedicate the research in the field of telecommunications only. And today where we stand, we will highlight. So that day when we separated out from the communication, Department of Communication, the focus was only to do the research in the telecommunication domain only, whereas the main department does research in lot of other areas also. So, sorry. So today's talk will be briefly on the understanding of the growth of communication. So why we came in the area of this millimeter wave, few applications that are coming up already we understood and we have not understood, expected to come. So the way the propagation happens actually in the physical world, the way the wireless channel changes and give the challenge to us. The existing channel models where people have struggled worldwide, where we are standing, for which 3GPP channel model to some extent they could get some shape, but that's not the exhaustive one. There were little research output in this channel modeling. Beamforming is the heart of this key technology that is coming up for this 5G and above. It's not about 5G, it's about the millimeter wave communication. If you wish to do, you need to have a beamforming technology and very strong beam tracking, beam refinement technology have to be understood and devised, without which this technology cannot come up. So channel modeling and beamforming was my preferable area of research on the last 6 years. So I love these 2 areas. I will love to be here a little bit more time. And then towards the millimeter wave networks, where my recently my activities have started that side, and what we understand for tomorrow's 6G communication also. So I will highlight as a list of application wise. How no, it's not something. This is a whole team in the School of Telecommunications under me only. So we are 7 researchers working, 7 faculty members working in the School of Telecommunication. We have above 60 PhD scholars in the School of Telecommunication dedicated for the research of this millimeter wave and above, 4G, 5G optical communications, and the merging of also the wireless over the optical communications. Towards that research also we are there. So in my team, I would love to say that core area is the millimeter wave communications, where the postdoc and PhD scholars are there. One or two of them are already graduated from the team, and they are doing their postdoc abroad. So then there is a massive MIMO. So massive MIMO come very wonderfully getting collaborated with millimeter wave, because you have very high frequency, so your lambda value diminishes. There is a possibility that really you can build up a system where a massive MIMO antennas can be fabricated over a very small area. That's where actually the real applicability of the massive MIMO comes into picture. Going ahead to a terahertz, the term that has come up with a supermassive MIMO structure, it's up to the device people as well as the engineers who are optimizing this design from the antenna side, integrating actually and completely understanding the total optimization required now, integrating the IF as well as the RF. More intelligently, we will be able to handle that impedance that is happening there, because with very high frequency, each and every smaller copper wire that you will be fabricating of your PCB will act as an antenna. So the job is how nicely we will be optimizing that radiation compared to your antenna, otherwise the whole beam pattern is expected to be damaged. You will try to turn the antenna beam pattern to some direction, it will be continuously going to other direction, but Satish was telling, because of these issues that we are not able to handle yet. So next is the area is the optimization. That's why the optimization was another interesting area that came into picture. Optimization starting from the circuit level to the signal level, to the signal processing level, to the network. So network optimization for your coding, modulation, your impedance handling, joint IF-RF antenna design to the network is another very nice area where slowly we are looking into. Visible light communication is an area that where the some part is going on, because we slowly understand for the short range communication for some specific application, this will also come up as a big wave as a service based research, for example your automotive radar driven some applications, and also the very high speed in bogie communication within a train and all that. And AI is overall everywhere. I mean, starting from the physical layer, merging the joint phi and MAC optimization to your complete transceiver design driven by AI. Some visionary person in the year of 2013 showed this in the EPFL, one workshop, that by 2020, automatically worldwide, we will be targeting and demanding that 100 Gbps wireless should be our target. Beyond 2019 or beyond 2020, everybody will start thinking that how we will transfer 100 Gbps over wireless communications. He didn't say that how long, how far, the distance why we should be able to, but dream should be something like that. If that is the dream coming up, then only at the back end, the network will be also coming up 100 times higher. So seeing that feature itself, today's this whole millimeter wave to the terahertz communication and the huge bandwidth release, everything. So automatically, slowly it happened, and it gave the indication that today, yes, we have this dream, we will be going ahead with this one in future. So question starts from here, what will we do with this huge bandwidth given and this huge amount of the data rate given to us? So the service is there, is any requirement there? A simple example I have given there, that if you go on for the very HD kind of the video transmission, minimum data rate requirement tomorrow is coming 5.6 Gbps. Today you are compressing the video and you are transferring. If I do not want any compressed video, if I wish to have uncompressed video transmission, so we need to leave the huge bandwidth. So the clarity, there's a demand that we have created for ourselves. Who told that you every day morning you wish to have a very nice kind of the video to be transferred, captured and to be transferred. Capturing camera technology, yes, it has been developed. Transmission, nowhere it is, because it is a power hungry, it is a bandwidth hungry situation. Other cases like these wireless data centers, all the data centers today, it is either having an optical fiber cable connection, or they are having at least a optical cable connection through the LEDs from the one section to the next. What about actually if I wish to do it completely wireless fashion? Why can't we give away there the very high amount, very pencil beam kind of the wireless communication from one server to the next? That's a server room. You can really control all those stuff, because nobody, much interference also will not be there. Servers will be static, there is no mobility. Even if your mobility is there, that will be for the human movements, and then you can also model and nicely control there. So why can't we do and erase all those connections? Second thing is actually from base station to base station outdoor also. The people are talking about the same thing, that's what he was telling, the backhaul communication, but no, it has not been framed currently in a proper fashion, but what actually was dreamed was something different. All your information servers, the very dense network with the IoTs, vehicular applications. So I hope you all know that government has already targeted the bullet train applications and all things are coming up, right? Where is the telecommunication network when you are sitting in Shatabdi Express, train is running at 100 km/h, you don't get any connection. So what about 350 km/h? We are really not ready. Worldwide, we are not ready with the telecommunication network with the extreme high speed of the bullet trains, okay? So there we have to start from the scratch. Forget about whether that network will be integrated with the 5G or 6G networks or not. Separately, if I try to think that for the vehicular communication, I will develop some new network, the technology needs to be completely different the way we are thinking about the cellular communication will be running. Cellular communication will never see a speed of 350 km/h suddenly. Even if the Volvo cars are coming up with, they will never run on the road at 350 km or 650 km/h speed, okay. Another case is, in the vehicular communication, the communication should not only happen between the pilot to the central, pilot to every bogie. Within the bogie, all the users will love to have their access their internet as well as the social networking at the same speed when they are static. That is the dream. So can you do that? So it is actually train to train communication, within the bogie communication, pilot to the central station communication, pilot to the cellular communication and standard infrastructure network communication. So like the smart city, it is a smart vehicle communication coming up. Can you now understand that sitting there, you can change your total travel plan. You are seeing actually somebody is giving you the information that whenever you will be reaching there, some kind of the jam and all stuff are there. Some services are broken. Can you immediately change, sitting in the train, your whole travel plan? That was the question. So seeing all these huge large channel bandwidth, spectrum scarcity and the data rate requirement all and the services that we are demanding each other, millimeter wave communication was the obvious way that we should move. And we should start from this point. 100 years back, a person from our country, he was the visionary person who showed us, look, one day 60 gigahertz communication will be in our life. Nobody actually claimed that and appreciate to that level. But see, that day itself, 100 years back, he demonstrated 60 gigahertz communication. Maybe with not a very fine art kind of the devices, horn antenna, phase shifters, all those power amplifiers, LNA, everything he himself manufactured sitting in that Bose Institute laboratory in Calcutta. And that setup, you read this material and the first patent that was published in the name of Professor Jagdish Chandra Bose, see the way he demonstrated it. So if that can happen 100 years back from this same country, today we should lead the world that we can do it. This demonstration, if it is possible, no, it should happen from this country only. So motivation, what will you get if you move to millimeter wave? Not only the huge bandwidth. See, once something is coming with very huge bandwidth and you understand that beamforming is the only way to reach your stuff, for given the question that we will be having a nice localization problem, if we can do that, see, we are actually getting a very nice application of frequency reusing. So space reusing also it's happening. So the one frequency I am transmitting to somebody in the same room, the same frequency I can transmit to somebody else. That freedom, it is another dimension. See, over the transmission, we have got the freedom over time division multiple access, frequency division multiple access, code division multiple access happened, space division multiple access, we have never done it. So that is either you call it a beam division multiple access or you call it a space division multiple access. Now you join all the combination of all these 4 dimensions. Can you imagine the level of the flexibility that can happen? See, this is the way where the enormous densification in the network can only happen. The merging of all these 4 techniques. Out of this, whenever I am talking about a beam forming, what am I doing, you know? Simply in the angle domain, I am designing my filters. We are very good in designing those in the frequency and time domain. only thing that we have to understand now, that when I am doing the filter design in the space domain, can I do it very nicely with the speed with which the thing is moving. So, it is the joint Doppler as well as means frequency as well as your space domain filter design. We have done it for the time frequency because delay Doppler domain we understood nicely. We have not understood how we will do it for the Doppler versus angle domain, or angle versus my frequency time domain, angle versus my delay domain. I need a modulation, complete new modulation technique. I need a complete new coding technique. Apart from that, I need actually this kind of filter design in the angle domain, right? But see, the spatial resolution is a resolution that actually at every moment wise actually it can be re-exercised and dynamically it can be changed because your location is every moment getting changed. So that's where actually AI comes into play because it is a very tedious job that manually you will be sensing and doing it. By that time the stuff will be out. So that's where actually you need to put the reinforcement learning, all the machine learning stuffs to actually understand and train the whole system in such a way that this can be optimally utilized and implemented. Very good point is, in order to do that, mmWave has already enabled us to use the huge antenna array design, understood? So till today, whatever the antenna design people have done and what exactly is the switching that people could do, I will tell you. But where the thing has to go and how much time we are having for that, that also we need to understand. Yeah, the antenna arrays are also becoming a heart of your whole system design and the transceiver design. It will be complex, but it is doable. These are the worldwide, the different frequency ranges and the application wise people are using currently. I would love to show you one area. See this 77 gigahertz, this automotive radar, it is not a dream now. From TI Bangalore, they have already done it. Transceiver is ready. They have put it on the video on the Volvo cars. The whole 77 gigahertz 4x4 MIMO transceiver they have already gifted us for the further improvement of the spectral estimation technique with IIT Kharagpur. I have shown it to Anshuman. So if you guys get some time, I really wish to invite you all. I mean, whenever you are towards that direction, please visit our lab to see the kind of the actual work going on there. So going ahead, if we are really demonstrating something in 77 to 81, that also with a massive MIMO structure, they have demonstrated and it is actually on the field here they have demonstrated in front of me. We can actually detect something at the gap of up to 30 meters, enough actually to detect your bumps, to detect your curvature that is happening, to detect with anybody who is there surrounding you, any car within 30 meters of yours, okay. So if that and the time of the detection that is happening with that is having extreme high resolution because it is a 77 to 81. If you do that bandwidth, 1 by that bandwidth, you will be in the nanoseconds level. So question is whether signal processing guys are that much intelligent to capture that signal and do the processing. Technology has the capacity to do it. So as they have done it, so I am pretty sure that going ahead, crossing 100 gigahertz is a matter of few years gap. Fine. Now we cannot question ourselves whether the devices are ready or not. Yes, the devices are ready. How can they do it? Their ADCs are working actually over the 4 gigahertz samples per second, 2 gigahertz wide bandwidth they have utilized. So they are all ADCs built in the TIs. They are working actually greater than 4 gigasamples per second. So if it is working, so why not for the cellular or the other communications we can utilize those ADCs and then make ourselves smarter for the signal processing, baseband processing stuff. So some applications we all know this, just I will pass this. The very fast link setup can be done actually for all these downlinks, the train station, accession and all this verification wherever you go. This with very less latency and jitter, less than 5 milliseconds earlier it was, but now it has even come down to the less than 1 milliseconds kind of the stuff for all your ultra high device service download and all that. This is actually the application that you wish to ensure when you are traveling in the bullet trains kind of, your communication virtual reality you should be able to see whenever you are moving at a very high speed. all the data centers, the connectivity, inter-rack connectivity should be wireless. There is no question of putting any wires anywhere there because everybody is static. You come with a dining hall, exhibition, flight, high-speed rail, bus, classroom. This is the information shower that should be actually making you up to date. Any moment, anywhere you go, the network should be with you. That's a Vodafone ad. Do you remember? That dog is moving, and then they used to actually, this has come to a reality, you know. Do you realize that? That time I don't know who made that ad, but today that is a reality. That wherever you go, the whole information, I should not say the network, I should say the information with the network is with you. So offloading, actually this part I should explain a little bit. See, traditionally we are really very good. We did the 4G and we have achieved a very nice data rate for the outdoor. Come to the indoor, actually whole data rate is gone. We cannot deny that fact. You go to the age of the whole cell, then also your quality of service in terms of data rate is out. That was the major problem, and we were trying to improve that. And for in 4G LTE Advanced, we have tried to do that, and we have done some solution also for it. But for indoor, the same problem left. So now for the 5G onwards, it should be ubiquitous kind of. For example, whatever the data rate you are getting outside, that same data rate people are demanding inside the high-speed rail. Same data rate we are demanding when we are actually below the mines and actually inside your indoor environment. Below mines, I don't know, but at least indoor environment to the outdoor environment, at least it should be ubiquitous, because indoor is, if you are even in a static zone, so it should happen.
How will that be supported?
Yes. So for that, actually people are thinking, actually if the outdoor is working at the 28 gigahertz with a 1 gigahertz bandwidth, indoor should be with the 60 gigahertz 1180 specification is already frozen. So it should be offloading to Wi-Fi, and then 60 gigahertz where AP will be working inside. So he will be taking the load of that. Exactly, and AP should be talking to the base station. At least that much MOU is done between your Wi-Fi versus the outdoors. So APs will be smart enough to talk to the base stations, 5G base stations, and away. If we are not going to do that, if that handshaking does not happen, ubiquitous transmission is not possible.
So sorry,
Yeah, please.
So the frequency of the AP and the base, like
that is a multi-rat, has to be. Inside it should be the 60 gigahertz communication, outdoor is 28 gigahertz. So offloading should be happening from 28 to 60 gigahertz. Then also there is a mismatch in the bandwidth also. So how will you in the indoor that data rate you will be maintaining and all that, that is a question of your plan.
Is that covered in
specification? Specification talks about, actually kept it open, that how to do this handshaking. Now the APs of the 11AD, they will be actually open enough, intelligent enough, protocol has been already given to share and handshake. AD is actually single user, X has come with MIMO. AY also you have seen that in China they have already demonstrated.
Wi-Fi offloading protocols are
Protocols are there. Question is actually whether technology handshaking has, you see actually physically finally you have to transmit, that has to happen. Signal processing guys have to decode, otherwise this whole problem of the standardization and everything is lost. I mean somebody sitting in the ground level has to do the research to make it happen. Then only the meaning of standardization comes into picture. So to make it happen again, people realize that the way we have designed traditionally the network side, that has to be diminished. See, everywhere we have done some redundant design. Every base station is having its own IF and baseband section. So the amount of the cost that is involved, the amount of the processing power that is involved, and also the latency that we are targeting, that is not going to work if we are going like that way. Fine. So if we try to also handshake the multiple base stations, exchange information multiple base stations, people came up with the fact, let's tomorrow we will have only the antenna and some part of the antenna circuitry with the base stations. That will be the definition of base station. Rename this as the radio resource head. Whole baseband pool, let us pool actually to a common cloud. Very big step according to my understanding, because I have seen actually these days Intel's all the projects are behind how to manage their high processing speed servers, how to do optimization, resource sharing, everything there itself. And biggest question, how to provide security? because multiple such base station signals sharing their baseband data there, and multiple they have to do the resource allocation, that also with that minimal way, minimal latency and all that. And another biggest question the people like us is, for example, I have captured my signal data, my user end to RRH one channel is already troublesome for me to do the channel estimation for massive MIMO, right? Then I am sending after that the ADC samples from the PHY, it is directly going to my cloud, and then cloud is doing all the business. So my channel from user end to me and my resource head to the cloud, they are not same. People are telling this side will be wireless, but your RRH to the baseband pool, that will be either your Ethernet port or will be optical. Channel suddenly changed, who will be doing channel state estimation for me? Where is it going on? Currently nobody knows. Fine. If I do it sitting on the RRH, I need to put some channel estimation block in RF, because my signals after RF got sampled and it is out. So I thought I will save the power, so I have not kept any baseband processing